Okay, so we're on page 8, and this is the first time that we're formally talking about what a function is. So we've actually been talking about functions for a little over a week now, but as we've been talking about them, I've just been saying in the back of your mind, just think of a function as something that you can graph. And then, do you realize we've started now? We've started. Then on page 5, we started talking about parent functions. So when I first started talking about functions, was just like, think about it as something that can be graphed. We talked about the domain of functions. Then we started talking about parent functions. And now we're actually getting to, well, what exactly is a function? So a function relates an input to exactly one output. So we put a number in, we get a number out. And not only that, but it can be one and only one number. So if I put in a 5 and it gives me a 10, then that's the only thing that can go with the 5. Every time I put in a 5, it has to give me a 10. It can't give me any other number. We know this as the input being the x and the output being the y. And then the sentence underneath it is basically the same thing that the first sentence says. It's like a machine where you put a value in and you get a different, in most cases, value out. So it's like a machine where we put a value in, we get a value out. Well, the machine is something that we actually do to the number. So we have this little very basic machine looking thing, and this guy, this x plus 7 is the function. So this is the function. It is the machine. And what this machine is going to do is it's going to take any number that you put into it and add 7 to it. So it's going to take any number you put in and add 7 to it. So if I decide that I want to put in a 5, then that 5 is going to go into the machine. It's going to have 7 added. So what's 5 plus 7? 12. And it's going to give me that as the output. So if the input is 5, the function adds 7 to it, and then gives me back out a 12. What this would end up looking like is a set of coordinates or an ordered pair at 5, 12. That makes an ordered pair 5, 12. I put an x of 5 in, so this would be an x of 5, and I get a y of 12 out. So how do we know when something is a function? So this little box below is just giving you the framework for how you know something is a function. So in this column, it's just an expression. But once you put one of these on, a y equals or an f of x equals, then it becomes a function. We also know some other names. We know g of x, and there's one more we see a lot. Do you know what one that is? H of x. So on this first one, it's just trying to indicate to you, you can write it either way. So f of x equals 5x squared minus 2 is the same thing as y equals 5x squared minus 2. So this is a quadratic that we have stretched and then shifted down. This next one goes from an exponential expression to an exponential function. So this one, I'm going to name him g of x, just so that I have some reference to the fact that you can name it y or f of x or g of x or h of x. And then this very last row just wants you to recognize that this goes from being an expression with a root to a function, a square root function, if you say y equals x plus 5. Or I'm going to do h of x on this one. So this table is just the very basic way of reminding you that we know something is a function if we put the y or the f of x equals on it. So the next step to this, knowing that this function will let us put a number in and get a number out, when we do that, it's called evaluating. So up here, we evaluated the function of x plus 7 when x is 5. So one of the key factors when you are evaluating functions is that it is extremely helpful if you use parentheses when you are evaluating functions. So I always remember how to spell parentheses because it's the three words parent, he, and sis, like sister, parentheses. Then the example to the right is just trying to show you how important parentheses are. So you all have a calculator in your little bin, so take your calculator out. And we're going to see what happens when we use parentheses and we don't use parentheses. So the first thing to note is that this calculator has a separate button for a negative and it's underneath the 3. So if you're trying to plug in a negative into your calculator, the first thing that you hit is the negative under the 3. Then you type your 5. And then you have an x squared button. It is kitty corner to the 7. So this x squared button will square. Oopsie. Yeah, I did it right. If you hit enter on this guy, it gives you negative 25. But if I decide to put parentheses around the negative 5, let's see if we get the same thing. So your parentheses are above the 8 and the 9. So your parentheses are above the 8 and the 9. So you hit parenthesis, negative, below the 3, 5, parenthesis, hit the square. What do you guys get? Positive 25. So, like I said, this is supposed to illustrate to you why parentheses are so important. This top one is telling you do 5 times 5 and keep the negative on the front. The bottom one is telling you do negative 5 times negative 5. That's why you end up getting the positive 25. So our first function that they want us to evaluate is a good example of where we need to use parentheses, and it's important to use parentheses. So they want us to evaluate this function for a bunch of different x values. And when they want to know what the function is for more than one x, the easiest way to keep track of your work is by using a table. So we're going to use this table to keep track of how we evaluate this 5x squared minus 2 at these different x values. So on this first one, how I would write it is 5. And then this is where we use the parentheses. Do a parenthesis, negative 4, square that, and then subtract 2 from it. So now I replace just that x squared with a negative 4 in parentheses. So now you can type this into your calculator. We do 5 parenthesis, negative 4 parenthesis, squared minus 2. This gives me 78. So when I put a negative 4 into this function, the function gives me 78. So that is what goes in the f of x column. If you plug in a negative 4, the function gives you 78. And now, part of why I like these calculators is we can just copy what we just entered and use it again to evaluate the next one. So I'm going to arrow up. You use your up arrows. You'll see a little black rectangle now on the function. You hit enter. So once you have the black box, you hit enter and it copies it for you. Then you can arrow over and just change that 4 to a 1. So if I plug in a -1, my function gives me +3. So this one looks like f of -1 squared minus 2 is equal to 3. So when I put a -1 in my function, I get back out a 3. Next one is 0, and I'm just going to steal that function again. I'm just going to go up and copy it. But this time when you do it, when you replace the 1 with the 0, you still have that negative hanging out. So you delete it off. The delete is right next to the left arrow. So you highlight it and just hit delete. And now you have what you need. This gives us -2. So 5 parentheses 0 squared minus 2 gives us -2. So you guys take 1 minute to get f of, or x is 1, when x is 1, and when x is 4. So you're trying to get the last two values. About 30. $20. $10. About 5. Okay, what did you get when you plugged in the 1? 3. What did you get when you plugged in the 4? Very good. So this over here is the last thing that we're going to talk about very quickly. What this is asking for is, what is the function when x is -4? And you've already found that. The function is 78. The middle one is asking you, what is the function when x is 0? And you found that it's -2. And finally, the bottom one is asking you, what is the function when x is 1? And it's telling you 78. That's where, it's telling you 3. That's where we'll start next time.